Let us learn equivalent circuit of induction motor. We know induction motor is just like a rotating transformer, so it will have primary circuit and secondary circuit. Primary is stator side and secondary is rotor side. Say this is induction motor with the stator and rotor. So we will draw here stator parameters. So stator has stator resistance R1, stator leakage reactance X1, and we have exciting branch also, just like transformer. This is what R0, X0. Here current we can say stator current I1, and here current will be I0. That will be distributed as IC and IM. Core loss component and magnetizing component. Supply voltage is V1. So this is what stator side circuit, and here EMF will be E1. Induced EMF here will be E1, and we have rotor circuit. So here in rotor we have E2R resistance, EMF, which is SE2. In running condition we know it, how rotor parameters are affected by slip. Then we will have rotor resistance R2 and rotor leakage reactance SX2. That is what X2R. Okay. Here current will be I2R. So this can be represented by the windings. I will eliminate these by windings. So it will be primary winding, that is stator winding, having exciting branch, R0, X0, X1J, R1. This is V1. EMF induced here is E1, and it will be E2R, R2 and SX2. Current here is I2R. Now this circuit can be transferred to stator side or rotor side. So before transferring, let me work on rotor side circuit. In rotor side I can write I2R equal to SE2, that is E2R, by R2 square plus SX2 whole square under root. We know this. So I can rewrite it dividing both numerator and denominator by S. I will have E2 by under root. This will be R2 by S whole square plus X2 square. Right. So rotor circuit will be modified as, this is rotor circuit, we have R2 by S and this is what? X2. And this is E2. From this we can write, and here current is what? I2R. So what is our objective? We need to eliminate S from both R2 and X2, because R2 X2 once machine is designed it will be fixed. So I am manipulating this, and while doing this we got we eliminated S from X2. Now this can be further rewritten as R2 by S can be rewritten as R2 minus R2 by R2 plus R2 by S minus R2. So R2 will be cancelled, right? This can be written as R2 by S. I can rewrite as R2 plus R2 1 by S minus 1. So we have splitted this R2 by S, in which S is variable because it is split. So this R2 by S is splitted in constant R2 with variable R2, right? Therefore rotor circuit will be modified as E2 R2 X2, and we have this as variable R2 1 by S minus 1, right, because S is variable. Now the circuit can be transferred to stator side, and while transferring a circuit to stator side, all rotor side parameters will be written as E2 dash R2 dash X2 dash, and circuit will be like this. So this will be what? Exact equivalent circuit. Let me draw first. So this is what R1 JX1, R0 X0. Here it is E2 dash. Here it is V1, current I0, IC, IM, X2 dash, R2 dash. Right. So I will write here R2 dash 1 by S minus 1. So this is what? Exact equivalent circuit. Exact equivalent circuit refer to what? Stator side. As this is three-phase induction motor, so equivalent circuit for any three-phase balance machine is drawn with respect to per phase. So these all values are phase values, right? And here transformation ratio K will be again E2 by E1, and we can say what is E2 by K is nothing but E1, which is equal to E2 dash also, right? Similarly, all values can be written. Transformation ratio I1 by I2 will be K. So just like that, we have I1 equal to KI2, that is I2 dash. So it will be I2R only. Here we have I2R current. Likewise, we can transfer all values. We know R2 dash will be R2 by K square, X2 dash will be X2 by K square, and this resistance is known as R2 dash 1 by S minus 1, which is nothing but load resistance RL dash. It is known as electrical equivalent of mechanical load. Electrical equivalent of mechanical load. This represents electrical load which is equivalent to mechanical load, right? If we want to draw approximate equivalent circuit, this exciting branch must be shifted here, and we can write this as approximate equivalent circuit. Approximate equivalent circuit will be what? we have this as exciting branch, R naught, X naught, and this is what? Variable load. This is R2 dash 1 by S minus 1, or R2 dash 1 minus S by S also. This is RE1, equivalent resistance of induction motor referred to stator side, J XE1, and here current is I2R dash. This is what? Supply voltage. So this is what approximate equivalent circuit in which the exciting branch is shifted just like in transformer also. This will be I naught, IC, IM. What about EMF expressions for these values? I can write as, from this circuit only, if I want to write here, this EMF is going to oppose this voltage, and I can write as V1 equal to minus E1 plus I1, here current is I1, R1 plus JX1, right? And what will be E2R? E2R can be written as I2R R2 plus J SX2 from this circuit. So I can write EMF equations also. Here we are using Lenz's law to be satisfied indirectly. That is all induced EMF are going to support flux, right? We are taking old convention. And I naught, we know that I naught will be IC plus IM. So based on this we can draw phasor diagram also. We will see it in next lecture.